You know, India's a big country with many states. It's very difficult for us to get out into the GIS community, and this event is quite unique for us in our ability to come in contact with so many people that have the same passion for GIS and mapping that we have. We've been investing millions of dollars now over the last 5 to 7 years building the Indian map. Our map covers 100% of population and main roads. We're covering 7,700 cities. It's an incredibly extensive map. We're very proud of it. I think what makes us a little bit unique from others is that we don't build maps to sell advertising. You know, we build maps for GIS applications, for enterprise, for automotive use cases. Our customers are some of the most demanding in the world, and that's reflected in the quality processes that we put into building our maps. We stand behind our map and the technologies that we use. In India today, we have a number of customers using our map. Maybe one of the most innovative is Rajasthan. They've made the decision that mapping is a critical reference point for a broad range of services. You know, that might be for planning the school locations, to planning service delivery, to, I guess, a whole range of, back office typical GIS applications. And by using the same reference map, they know that they're getting the best possible solution delivered consistently throughout their organisation. We also do a lot of work with the automotive industry. Honda use our vehicle, Honda use our maps, as well as Maruti and a lot of other companies, and they use that because of the navigation. You know, one thing about maps is that navigation is a good test case because you need a lot of attributions. If you're guiding someone in real time, then you need to have, you know, up-to-date information about the road network. Safety is important. You know, you can't have out-of-date, speed sign information, stop sign information. And so we put a lot of work into that, and we believe, you know, that the automotive industry is responding to that quality, and that's reflected in the uptake of maps that we've seen from the navigation use cases. We're also very excited, if I could just for a minute, talk about our LiDAR vehicles. And I think, you know, if I just take a step back for a moment and talk about here maps, in terms of our history, you know, we began building maps before Google existed. So we have mapping patents that exist before Google even came about, the Google search. So we've I guess over 35 years, we've been a pioneer of, the evolution of mapping technologies globally. And I guess historically maps have been 2D, then we saw 3D maps starting to emerge. And now what we're seeing is the emergence of LiDAR. And for those of you that don't know what LiDAR is, it's basically, a vector point. And when you start to collect billions of vector points together, you can actually create a mathematical model of the streetscape. And that gives you enormous possibilities in terms of, management of street furniture. We've had, utilities companies come to us. One of the biggest problems they have is trees growing into power lines. And so what they can do, they can geocode the trees, okay, and then they can actually then model, based on different trees growing at different rates, what the actual impact on the power lines will be, and then they can measure it. So LiDAR gives you the ability to be able to measure information, which is, incredibly powerful. Geocode street furniture, where the manhole covers are, what the conditions of the roads are. The spin-off of that data will be the formation and the foundation of autonomous driving. When you build an autonomous vehicle, there's two things you need. Obviously, you need the sensors around the vehicle, because that gives you the immediate assistance to the driver, but you need to have visibility into the future, because you need to know what lane you're going to get into if you're going to turn up ahead. And so you need to have highly accurate information about lane widths, lane locations, stop signs, all of that, infrastructure that exists on a road that allows you to, progress safely through the traffic. And that's what LiDAR, and that's what the autonomous vehicles are going to be using, and that's what we call our HD maps. And so the LiDAR vehicles, as I mentioned, it's great application within utilities, municipal councils. In the Philippines, we're embarking on a major project to digitise their entire road network with LiDAR, so they can actually manage and understand what bridges have been built, what the height of the bridges are, what the elevation of the roads is, what the state of the roads is. So all that stuff is coming, and then they can also use that as part of the autonomous vehicles, which is happening at the moment, in terms of, as I said, being able to look into the future, give the map and the car, that sort of glimpse of what's up ahead, so that we can progress safely, because that's critical to the evolution of autonomous vehicles. It's an exciting time to be involved in maps, and I think here is going to continue to pioneer, the latest technologies in terms of map collection, map processing, and map delivery to its customers. We need to step back and look at this, okay? So there's competing requirements. Obviously, there's the need of business and governments to have access to information, detailed information about their cities that we live in. But also, on the counter side of that, we need to make sure that the information that's given out can't be used in a way that's negative towards the population. And so other departments, I guess, have a role to restrict and manage the delivery of that information. We respect that. We think that the two of them can be complementary, provided that they're managed sensitively. And so one of the things that we do is that with the technology that I spoke about previously, this is the LiDAR, the street level imagery, what we're doing is we're building a service which can be managed in-house by these companies. So we don't have to publish it through, the web through street level imagery. That we can over time when the proper policy is in place, but that's not where we begin. We're beginning with governments, with military, with departments that need that information for public safety, for planning, but they don't necessarily want it to be freely available. So that's the strategy that we have of our go-to-market. Our go-to-market isn't actually to make it available through the broader web. Okay, so we think that's one way that we can start to, I guess, give these policymakers time to understand the technology, to understand the processing of the data that's required to keep it safe. By processing, what I mean is being able to blur faces, remove registration information, make it anonymous. Okay, that might mean getting rid of buildings. Okay, so there's a learning and a sort of a sensitivity that the policymakers can go through and experience by using it themselves, and then over time we can then release it for public good. So we think that's a manageable process. I think what you're saying is, how are we managing the tension between traditional surveying methods and the move towards digital maps? Because that's really what you're asking. And look, it's a difficult one because, obviously there's a lot of jobs at stake around traditional GIS. And as we move to digital and we move to sort of global sourcing, there is some substitution that goes on there. We understand that, okay? But I think what's happening too is that the amount of investment that you need to build the highly accurate, detailed maps, the R&D that's going on, can really only be monetized through a global customer base. Okay, and that's what we're seeing. And so, how do you update the map of India? Even a city now, the cities are changing so much. You just can't fund practically the teams that you need to be able to manage that on scale. And so that's where we're starting to see some rationalisation of thinking coming in. So, more and more we're supplementing some of the traditional surveying. We had the guys come through before, asking us about it. And what they're doing, they're taking our base map and they're overlaying data, which we're comfortable with, And slowly, more and more, they'll be more confident. They can adjust their sort of, I guess, their map building methodologies, and they can start to embrace. I mean, the biggest change has been the cloud. With maps available on the cloud now, paper maps are just about dead. Traditional surveying is sort of slowly changing, and the amount of information now that you can get through the web is just incredible. And you saw the LiDAR measuring tools. I mean, being able to measure in 3D, that's pretty compelling, isn't it, really? So I think there's just a natural evolution that's going on of substitution, but it's taking time. And there's also fear that if we put the reliance in somebody else, that if we come to need a map one day, maybe there'll be no maps. And I think that's being balanced by, I guess, this. We're a big company. We have deep commitments to some of the major, as I was saying, every time we check in on Facebook, that's using a HERE map. We have about 4 million vehicles now globally that are being asset managed on the back of our map. We have about 10 million cars a year that are sold with navigation that have our map. These are some of the biggest companies in the world. So our longevity as an organisation is guaranteed, decades into the future now. And so that gives these companies confidence to step away from traditional practices of sourcing themselves and look towards partnering in a digital domain with, I guess, best of breed maps. We have daily updates now. That's where the world's going. And that's also going with satellite as well. And we don't supply satellite, but, I know from the satellite providers, they're looking to increase their frequency as well of updates. It's difficult in traditional surveying methods to do that unless you put field teams out. Very expensive. We see there's a huge issue there about management of power line infrastructures. I think telcos, service delivery is really important. Being able to verify the location of a subscriber, when they ring up, can you confirm that the actual service works there? Can they get mobile reception? There's a lot of work going on in the telco sector for us. Security, defence. I think the LiDAR data that we gave you can actually model sniper shots. So you can actually look at a building and actually work out, can someone shoot at somebody standing on a platform? You know, these things are critical. You know, being able to give tools in the field that work offline. You don't need to be connected to the network to be able to get access to maps. And traffic planning. So we have a lot of the departments now looking at our data. We have historical information. We have real-time traffic information. We're for 23 cities now. And now what we're doing is taking that and actually creating predictive traffic. So being able to put a timestamp in the future and then being able to actually understand what's the best route to take. So there, I think that's 5, is it? I've counted correctly? Good question. Thank you.